Uh-huh.
Well, you
The
changed your you changed your the size per epoch, right? And so it probably ran out of data to run it against because you went
Sorry,
from
please
two.
continue.
All right.
Yeah.
So we went and the 60 lines of code looked very enticing. And so we went and started working to build that out. And on Craggle, I created an account so I could download the data set, but the data set's private for that. And so that blocked us. So then we moved to the awesome uh, unit, and that's a really great one to get up and going, but it's mammoth. And we started downloading the data sets for that, but it'd take about 45 minutes to download. However, we did go through the README and their results that they had indicated, and they had called out that the UC Transnet from that model from the awesome UNet of all the test results, that was the one model that had the highest results. So then we thought, well, let's go to that one. Maybe we'll have success with that. And so we went to that one and struggled with the requirements.txt. I was able to get the packages and get that resolved so we could get something up and running. And we were able to download the data sets for that. So from that GitHub for UC Transnet, we have a working example that's up where I can train it and test it. And then we all got back together. So what I was sharing on the screen was just another iteration of the testing where the epochs, 2,000 of them with a batch size of 10, and then it had just broken out based on the early stop count. But in looking at this and the way it's set up, initially we were about 0.35 on our loss. But as it went through these iterations, we got down to 0.21. And I think if I had maybe changed the batch size back to 4 and do a few different things, this one had about a 98% accuracy, give or take a few points there. And so we just ran out of time at that point. But we were able to go get it, get something up and going, get something working, start to see our loss reduce, and have a starting point to continue the a journey. Ryan, Lily, any other thoughts on what we did?
No, I don't think that there was anything else that I wanted to add. We did find a data set that we were going to be working against in applying it into that 60 lines of code that we pulled down that was promising, but we Sarah got a little farther on this, so we figured we'd show here.
Okay. Did you try an original image and see how well it could segment it?
No. We had the hope that we could get one just simply working as is and then start to play with it. But to get it just literally so that it runs, that it started running like 10 minutes ago. So that's the challenge.
Yes. So, no, this is correct. And TransUnet is one of the more recent and more powerful variants of UNIT. I was going to, actually, I may have put the paper on the course portal or not. I don't think so. But it is one of the more recent work in this space. It's better than the vanilla unit for sure. So good, nice that you tried this. One lesson to learn with all of these models is when you train them on huge data sets, it does take a long time. And what's that? Anybody else would like to? So again, good job, guys. Nice that you tried. You got this model, you trained it. Feed it a new image, see how far it takes you.
Yeah,
what do you
do
get?
training? We just put image and try running. We got to mask. Not for that